Hello friends, in today's question, a solid sphere of mass m and radius r is divided into two unequal parts. The first part has a mass of 7m/8 and is converted into a uniform disk of radius 2r. The second part is converted into a uniform solid sphere. Let I1 be the moment of inertia of a disk about its axis and I2 be the moment of inertia of the new sphere about its axis. The ratio of I1 to I2 is given by, so we have these four options. So we are given that there is a solid sphere and whose mass is m and radius is capital R. So this is solid sphere having a radius r and mass m, and it is divided into two parts. First part is a disk. The radius of this disk is given as 2r and its mass is 7m/8, and the second part is a sphere and whose mass is not given. I think it should be given. It should be, I think, 1/8m. Okay, so let me sphere, 1/8m. So this is our first part and this is our second part, and let us suppose the second sphere is having a radius of small r. So let us call this as original sphere. Okay. And we consider that the density of the original sphere is given as rho. You can say density of original sphere is given as rho, and therefore this rho will be equal to the mass and its volume. Volume will be equal to 4/3 pi r cube. So if we substitute it here, we get this m. This will be about 4/3 pi r cube. And the second part, or we can also call this a second sphere. And we assume that the radius of the second sphere is small r. You see, let the radius of second sphere is small r, therefore mass of second sphere, which is given as 1/8 times m, and this will be equal to volume of the second sphere multiplied by the density, because the density in all the objects, or rather we can say original sphere, the disk, as well as second sphere, so this is our disk, will be same. So this will be our density multiplied by volume of second sphere, and volume of second sphere will be given as 4/3 pi r cube. So substituting the value of density as well as volume of the second sphere, can further write this equation as 1 by 8m is equal to m divided by 4 by 3 pi r cube multiply by 4 by 3 and pi r cube m cancels with m, 4 by 3 pi and pi goes, and from here we can say that our ratio of r cube divided by capital R cube is 1 by 8, or we can say that radius of second sphere is equal to radius of original sphere divided by 2. So we got the radius of the second sphere. Okay. You can say this is radius of second sphere. Now we are supposed to find out the moment of inertia. I1 is for the disk. Okay, so you can say I1, which is equal to moment of inertia of disk about its axis. About its axis will be equal to the mass. Mass is 7m by 8 multiplied by radius. Radius is 2r square and divided by 2. So it will be 1 by 2 mr square. So we can solve it further. We get this I1 will be equal to 7 by 4 mr square. So this is the moment of inertia for the disk. Now I2 is the moment of inertia for the solid sphere, which we can say for the second solid sphere. I2 is equal to moment of inertia of second solid sphere, and that will be equal to 2 by 5 multiplied by mass. Mass is m by 8 and multiplied by radius. Radius is capital R square and its square, r by 2 sorry, and its whole square. So therefore we can say our I2 will be coming equal to as this will be 2mr square divided by this will be our 5 multiplied by 8 multiplied by 4. So this goes by 2. So we get this as mr square divided by 80. So this is value of I2. We are supposed to find out ratio of I1 and I2. Therefore I1 divided by I2. I1 was 7 by 4 mr square and I2 is 1 by 80 mr square. Mr square goes away and we are left with this will be 7 into 80 divided by 4, and this goes by 20. So you can say I1 by I2 is 140, or we can say the ratio of I1 to I2 is equal to 140:1. Therefore the correct option is our option number D. So you can say correct option is D. This completes the question. Thank you.